Okay, let's get started. A very good afternoon to all of you. And today we are here for this Cloud Tech Bootcamp in partnership with Cloud Management Insider and in collaboration with Vivekanand Institute of Professional Studies. A special thanks, and we are really very grateful to Dean VSIT Vivekanand Institute of Professional Studies, Dr. Supriya Madan, Faculty Coordinator Dr. Dheeraj Malhotra, for having us here and giving us this opportunity to interact, to connect with the students of VIPS. We are all looking forward to interact, to share and learn from the students. The Cloud Management Insider team, I'm very thankful to them for providing me this platform. Cloud Management Insider is the most exclusive cloud management community out there. They work with the sole purpose of providing information to the cloud enthusiast and help them understand the cloud technology better. I am thankful to them to provide me this platform so that I can connect with students, share my knowledge, my experience, and also learn from them. It's a great platform to stay informed, to be inspired, and to engage. Allow me a minute. I am Amit Kumar, and I have been working in this domain of technology, infrastructure services, solutioning, and architecture for over a decade. I have expertise in planning and designing large-scale cloud transformation and migration projects, and I really love talking to my clients, helping them solve their problems in the domain of cloud platform. I am equally looking forward to connect with you all. I request you to please be as interactive as possible. The chat room you can use to pose all your questions throughout this session, and we have a dedicated slot of 15 minutes wherein we can take all the questions at the end. Let's get started. So here's the agenda for today. We will spend around 30 minutes to understand what AWS Public Cloud Platform is, what are the basic building blocks, and some of the core services of AWS Public Cloud. And during this session, approximately 5 to 10 minutes is reserved to take you through the definition of public cloud and help you differentiate between what an on-premise offering is and how does it differentiate with the public cloud offering. Why is it that today everybody is looking to move their infrastructure on the public cloud? So that's the agenda for the first 30 minutes. Followed by we will do a small demonstration. We will spin up a WordPress website, and you'll see that how a managed platform without any server provisioning or network provisioning or storage provisioning can be spun up. And then we'll go ahead to see a chatbot implementation, demo chatbot implementation. Followed by that, the last two agenda is completely focused upon what is the importance of public cloud as a career outlook, and how is it that the AWS certification is going to help you accelerate your career outlook in this domain. So we'll be focusing completely on that. So let's get started. Let's try to sneak into the AWS public cloud platform. But as I said, first we will understand what a public cloud platform is. But even before we define and even before we understand the differentiating factors or the factors of advantage over on-premise, let's understand what is a data center and what is it made up of. So typically a data center is where you host your applications. And to start with, the most basic thing is that you require a real estate wherein you can build this infrastructure, and followed by one has to procure servers. They have to procure switches, routers, and firewalls to establish their network, to establish their security layer. And then you need storage so that you can attach it to your servers as a disk, and then you can use the same storage for storing your object data, your files, your media files, and things of that sort. Of course, the power to run all of this infrastructure, the cooling to keep the temperature of this huge, humongous infrastructure in control. And yes, apart from the internet security, the network security, and security of your application, you also need physical security, because the data center has to be physically secured from unauthorized access. So you see, these are some of the building blocks. Not that these are the only blocks, but these are some of the basic blocks that is required to put together to build a data center. Now, all of these blocks, it requires a heavy investment. You have to procure all of this in a huge amount before you start your first application. Now the question is, if data center is made up of these components, what is it that a public cloud is made up of? Don't be surprised. This is exactly the same as a data center. It's the same component, the same building block that will made up that is required to build a public cloud platform. You see, now the question is, if the same blocks are being used for your data center as well as for your cloud platform, then what is the difference? The difference is in the way it is consumed. The difference is in the way the infrastructure is provisioned to the end user, not the provisioning of the service provider. So you see, the definition from the US National Institute of Standards and Technology says that any infrastructure solutions provider should provide these five basic features to call themselves as a public cloud provider. Now, what are these features? The first one is on demand and self service. So as a customer, if I have to provision an application, and for that if I need an infrastructure, I should be able to get that infrastructure on demand. I do not have to go through the entire cycle of procuring hardware, installing the hardware, provisioning the network, the storage, and connectivity to internet and security, and then start building my application. No, I should be able to create a server on demand and also in a self-service fashion, which means I should have a console from where I can go ahead and select the set of services that is required for my use case and simply provision it. So a public cloud platform should have this first and the most common and basic feature of on-demand provisioning in a self-service manner. Second, it should be accessible from anywhere. You see, in a data center, when an enterprise, or even if not an enterprise, let's say if there's a startup which is starting with just two guys having some great idea, and if they want to start building that particular idea, of course, a technology has to be put in place. Now, connecting to the on-premise again requires an infrastructure at your end as well. An enterprise has to establish a secure connectivity to the data center so that they can connect from the perspective of managing the infra. Right now, there are two connectivities that we talk about. One is connecting to your application over the internet. Second is connecting to your infrastructure so that you can do day-to-day tasks, server management, infrastructure management, administrative tasks at the OS level and the application and the DB level. This connectivity to your infrastructure is something where again a company has to invest, and rather than company, I would say a consumer or user of the service has to invest. Now the other thing is, it gets established between your premises and the data center premises. Of course, there are options wherein you can establish a point to site connectivity also, but then it's not accessible from anywhere. When I say accessible from anywhere, you can simply go to your internet, open the AWS web console and start provisioning your services, and that's how easy it is. So your access to the infrastructure is something which is available from anywhere. You just have to feed in your credential, authenticate through a multi-factor method, and start provisioning the infrastructure. So that is second important criteria. The third one is the provider should have a pool of resources from which it will be allocated to the customer. Now you see, when we were trying to understand what are the basic building blocks of a data center, we were trying to understand that there has to be a heavy investment, heavy lift and shift that has to be done before we start using that infrastructure. And moreover, it's not a pool of infrastructure. It's a set of infra that you have planned, let's say for a period of 3 years or 5 years, and you are now invested in that, and you have to continue using that. You can upgrade it, upscale it, but not downscale it. But here, a public cloud provider sets this entire infrastructure, a pool of infrastructure, and from that pool they will provision it to each and every customer. Now the question that arises over here is, if public cloud provider has a pool of such resources and every individual or every company is going to use from this pool, what is the security? To stay assured, the way this platform is built and the way it is orchestrated, security is something which is paramount and has been given the highest priority. The underlying infrastructure is secure as per all the global auditing standards, and anything that is built on top is completely isolated. When we go ahead to understand some of the basic and the core services of cloud, we will see that you create an account and then you create a virtual private cloud which allows you to restrict your infrastructure, your data with yourself. So there is no sharing of infrastructure at the account level or at the provisioning level on top of this, the basic underlying infrastructure. So it is secure, but yes, in the back end, it's a pool of resources, and every customer gets a piece from that. Elasticity, the most important feature of a public cloud platform. Once you have started using an infrastructure, elasticity has been a big problem. Either you are over invested or you are simply undersized and under invested. In both the case, it's a problem for the business. Now, let's say, think of a scenario wherein a Flipkart or any of the e-commerce giant has to do a 1 day sale, right? The amount of traffic that would be hitting their e-commerce site would typically be 10 and 100 times more than the usual traffic. To handle that amount of traffic, one has to have a large set of infrastructure which is going to withstand that. Now, just for 1 day in 365 days, nobody would want to invest in that sort of infrastructure, because apart from that particular day when the sale was conducted, all the other days your infrastructure will lie wasted. There's going to be a huge amount of resource wastage. All right. Now that restricts your capability. That forces you to invest more than what is required, and you don't have an option to use that unused infrastructure. On the other hand, you don't have the option to be undersized, because you have to support the business function, right? Now, with a public cloud platform, the orchestration is available to a level such that you can scale up from one server to 100 or 1,000 servers, and you can scale down immediately as the traffic goes down. That's the power of public cloud. So you can design your infrastructure to be highly elastic without over investing in your infrastructure. That's the most important thing. Finally, the fifth criteria, as per the standards, is that you should pay only for what you use. Now, that's something which every client loves about, is nobody has to make any upfront investment. You don't have to pay for the infrastructure that you have to provision. You pay only for the amount of time that you have consumed that particular service. So let's say if you're starting a server and you're using it for just 1 hour, you will pay only for that 1 hour of usage. No upfront investment and no payment of no consumption beyond what you have used. It's like utility. The moment you turn on your utilities, like your electricity, or let's say your postpaid bills, if you're not using it, if you disconnect it, you're not going to pay for it at all. Your electricity is the best example. So you compare it with a utility. As long as you're using it, you will pay for the consumed units. I've just added these points to differentiate that here one has to plan and provision in advance. The access is restricted to your on-premise infrastructure, on-premise network. This is a private infra as compared to a pool of resources which is built and managed by the cloud provider and provided to their customers. Then over here we differentiate it by saying that the scale up has to be planned, and scale down is not possible because you have already invested over there. No matter whether you use it or not, you have invested in that, and if you're not using it, you're simply wasting your resources as well as the investment that you have done. Here, the last point, as I said, you have to pay only for what you use, but in on-premise, you have to make an upfront investment in all of the components that you saw. Okay, so that should help you differentiate between what a data center and what a public cloud platform is. Just to end it, I would say the basic building blocks, the underlying components are same, but it's just that the way you use the service, the way you consume the service, the self-service manner, the on-demand manner is what differentiates the cloud. And also, not to forget the pay-as-you-go model and the elasticity and the security that it provides, right? Let's go ahead. Why public cloud? So you see, when you have your infrastructure on premise, the administrative overhead of managing the infrastructure is so huge that you get very less time and effort and money to invest in your business ideas. You get less time of your technology workforce, your developers, your database administrators, your server administrators, to focus on the business outcomes. Most of the times they are involved and they are busy managing the IT infrastructure. Now that's a huge amount of investment, both in terms of money as well as effort. Now what happens with public cloud platform is the management of cloud infrastructure is something, the underlying infrastructure, the hardware, network, connectivity, security, everything is hosted with the public cloud platform. All you have to do is just invest 30% of the time of your total IT workforce time to manage that cloud infra, which includes provisioning and some of the tunings and using the services from the self-service portal. And the rest of the time gets released for business innovation. Now that's something where every company would want to invest and achieve, because every IT department of any company has a business objective to achieve. It could be improving the performance of the application so that they can deliver a good experience to their customers, or automating their processes so that they can improve the faster time to market. They can use IT to improve the quality of their product, design it better as per the changing needs. So you get a lot of time to invest in business innovation, and the administrative overhead of managing the infrastructure now lies with the public cloud provider. So that's why you see everybody is now choosing a public cloud over an on-premise infrastructure. I'll just quickly repeat. If you have any question, please put it in the chat, and the CMI team will help me collect all the queries. And at the end, when we have the Q&A session, I will answer all those questions. Now let's start with AWS Cloud. Let's first understand how is it that they implement. We understood some time back, public cloud platform in the backend is nothing but a data center. Now, how is it that AWS has implemented its global infrastructure? So you see, one of the first definitions is that of a region. A region is nothing but a logical boundary which represents a geography. Like for example, in India, we have Mumbai region wherein AWS has its infrastructure hosted. Likewise, they have a lot of regions. In one of the upcoming slides, I will show you the geographical expanse, the coverage that AWS public cloud provider provides us. So you see, region is nothing but a geographical boundary, and in every geography there is something called as an availability zone. So minimum there will be two zone in any region, and it can go up to 3 and 4 as well. Now, what is this availability zone? An availability zone is nothing but a cluster of data centers. So now you see the amount of high availability, fault tolerance that we are able to achieve without investing even a single penny. Now let's say if I have to start an application, I may have some idea and I want to start an application. I don't have to invest and build a data center so that I can start building my application. All of this infrastructure, the data center and everything is already built and managed by AWS public cloud platform. So availability zone, as I was saying, is a cluster of data centers. Now all of these availability zones are connected to each other on a very low latency network, and it is low enough to support your database clusters. Typically, in an on-premise world, in a physical data center world, a cluster is implemented, in the same network, because it has to be connected through a very low latency network, so that database transactions which is committed on a master server should also be available on the second active server, for an active setup. But here you see, we are going far beyond the local network, and we are allowing the users, the consumers of the service, to create clusters in two different physical locations. Now that gives you a great amount of fault tolerance and high availability. Okay, so that's the power of the physical construct of this AWS global infrastructure. So you have a region. Within region, you will have multiple availability zone, minimum 2, and an availability zone is nothing but a cluster of data centers. So you see, now this is the expanse, this is the global spread of the AWS global infrastructure. They cover 245 countries and territories in total, and they have 73 availability zones. Direct Connect, they have 97 locations. Direct Connect is a way to connect an enterprise network directly with the AWS network, right? Enterprises, typically the BFSI sector like banking, insurance, healthcare industry, they prefer connecting to the public cloud provider directly through a private network rather than having that traffic going through the internet. It is for compliance reasons and security reasons. So they provide 97 such direct connect locations so that you can connect and have your internet, your data transfer and everything happening through a private line. They have announced 4 new regions all over the globe. They have 23 regions, and they have 2 times more region than any other competitor in this. and then there is a local zone concept as well. What I'd like to take your attention towards is a point of presence. In the coming slide, when we are talking about services, we will talk about this again. It's a content distribution network. They have 216 such point. Recently, last week, they announced one more point of presence in the state of West Bengal in Kolkata. If I remember it correctly, there are total 11 such point of presence: Delhi, Mumbai, Hyderabad, Bangalore, Kolkata, and some other cities. Now, what is this point of presence? We all have been using Netflix and Amazon Prime, all of these streaming services, or in fact, not just streaming services, any website which is hosting media files or things of that sort. They always want the performance of the website to be faster. Now, the way your laptop caches, creates a cache of the website recently accessed. Similarly, this is the point where your media files and your recently accessed web pages and all get cached, so that the user gets it delivered faster. The page loading time is faster. So this is the same concept. We will discuss a little more about it when we are talking about the core services of AWS. Okay. So what is it that we are going to cover today? I mean, you see there are a host of services, tons of services, I should say, and but of course we will be focusing only on few of them. We will first talk about security and identity compliance, wherein we will be discussing about how is it the users are managed, user roles and the groups and the permissions are managed, what are the features available. Then we will talk about networking and content delivery. We will talk about how is it that we build a network so that I can create a machine in it and they can talk to each other. And then we'll also talk about content delivery. I mean, the point of presence, which we just discussed, we'll talk about that as well. We'll talk about storage. What are the various ways in which you can store your data, in which you can access your data. And then we'll also talk about compute. Now, what we're going to do while we are discussing about the services is we'll try to understand what they basically mean, what is the term or terminology used by AWS for those services, right? And at the same time, we'll try to construct a very basic architecture of a web server. So it will be a two-tier application wherein there will be a web app server and then there will be a database server. So we'll see that how is it that all the components that we are going to come across in the coming slides are put together to design an architecture. Okay, an architecture which is as per the client's requirement. Okay, of course, I mean, I'll call out a disclaimer that the architecture that we are going to see is not the full-fledged architecture. There are many components that have to be put together from security perspective, from availability perspective, and fault tolerance perspective. But this is just a basic construct to give you an idea of how easy it is to achieve a two-tier application on the public cloud platform. Okay, so let's start sneaking more into each of these services. As I mentioned, first we'll start with the identity service. Now, what is identity services related to? For any service, you have to have a mechanism to allow authorization and authentication of people who are accessing your infrastructure, people who are doing the administrative task. The task can be defined into various roles or graded into different roles. Some of your administrators could be just a read-only administrator, who is just monitoring the infrastructure. Then they could be administrative users who have all the rights. Then they could be users who have access to all your billing related data. So likewise, you can define users, their roles. You can create groups so that the same set of identity can be attached a set of policy and things of that sort. So let's see some of the building blocks. IAM user. IAM is nothing but identity and access management users. So AWS Identity Service allows you to create users so that you can assign security credentials, access keys, passwords, multi-factor authentication through various ways. You can provide multi-factor authentication through a hardware token or a software token. A software token example is a Google Authenticator that you can download from the Play Store and then sync it with the AWS when you log in. And then every time you log in, first you'll be prompted to input your password, and then you'll be prompted to enter a passcode or call it an OTP, right? Now, so with this service, you are able to create users. As I said, you will be able to assign various policies. So we use a term called role-based access, right? Now, this is very important methodology, very important practice to control who has access to what services and up to what level. So, a role-based access is something which is very effectively achieved through this IAM services. Now, allow me to mention that this service is completely free. You don't have to pay anything for creating users, managing policies and groups and roles, right? Now imagine having the same kind of functionality on premise. You certainly have to invest into an identity service, right? But that's not the case with the public cloud platform. This is absolutely free of service, sorry, free of charge. Now, roles, when you want to define a particular, what do you call it, a service to talk to another service. Now, when let's say a server is talking to an object storage, right? Now, they will not, it's not a good practice to hard code the username and password in your application, which means if by any means your application gets compromised, the security of your application gets compromised, the attacker or the hacker would be able to read all the username and passwords, which is going to be really disastrous. That's why AWS provides this feature of rules, which provides entity, allows entity, one entity to connect with the other entity using a secure token, using a secure token which is time bound, which keeps getting rotated automatically, and there is no need to create and store passwords in a hard coded fashion. This is the most effective and the most secure way for allowing two different services of cloud to talk to each other. When we look at the architecture going forward, we'll see where would be a case wherein two services want to connect with each other. Now there's one more service called federated users. So let's say you have built an application and you want your users, your visitors, to log in onto your application using their existing Gmail account or their Facebook account or an Amazon account or even an enterprise solution like Microsoft Active Directory. So AWS provides this federated user service wherein you can achieve a single sign-on using an identity, a username or password that you are already owning. Nobody wants to create hundreds of passwords for 100 different applications. Single sign-on is the easiest way to have to get yourself connected to various applications. So AWS allows federated users to log in onto the application. That has to be enabled. There are services like Cognito services that allows you to do such kind of federated access mechanism. Okay. Now let's see, as I said, as we go through the services, we'll also try to draw an architecture. Let's see, with these set of services and after understanding the concept of availability zone and region, what is it that we have on the architecture front. So the first and foremost thing that anyone has to do is to create an AWS account. You can use your ID, any ID, your email ID, your Rediff mail ID, or your organization's ID. You can create an account. You will be asked to feed in a credit card information so that you can be billed as per the usage, and then you'll be up and running with an AWS account. The moment you create an AWS account, the first thing that gets created is your root credential. So the ID, the email ID with which you have created your account becomes your root user. And then further, you can go ahead to create more users so that they can perform administrative tasks. It is a best practice and highly recommended that you do not use your root credential for day-to-day administration, because a root user is something which has access to your entire account, and they can even go ahead to delete your account, after which nothing would be recoverable, right? So typically, not just typically, I would say we make sure that whenever we are provisioning an infrastructure, after creating the root user, the next thing that we do is we create another administrative user who can do all the administrative tasks, right? So you create an account, you create after that a default root account is created. You go ahead to create an admin account. Then you select a region. You see, one of the advantage of public cloud is that you can create your infrastructure in any region of your choice. This, of course, is not possible when you're hosting your infrastructure on premise, right? Because you have to invest. Once you have invested, you have to wait for a return on investment, without which you will not have fund to start your services in some other region. But in AWS, be it a student or be it an enterprise, you can start with any region of your choice. I can select a Mumbai region, or I can choose a region in US if the users or consumers or the target audience of my application is in US. Why should I host the infrastructure over here? I will host it closer to them so that the performance of the website is faster and better. So, right. So the next thing that we do is we choose a region wherein we want to create the service. Availability zone. Go back some slides back. We spoke about the concept of region and availability zone. I have the option to choose an availability zone of my choice, and then see you I'm just trying to define some of the actors. So there will be an internet user as well. So until now, by the definition of the global infrastructure, the construct of that, and after understanding the identity solutions, this is what we have reached. Now going forward, we'll understand what are the networking components, and as we discover the services, we learn the services, we'll try to build this architecture further and see what is the outcome of it. So let's now talk about networking services. Of course, you need networks. Without network, how will you have your services talk to each other? How will you have them connected with each other? How will you have the internet connect to your application, the internet user connect to your application, right? So what are the services? How do you implement a network? Even before I define that, let me put forward a point that if you have to implement all of this on premise, as I said, procuring hardware and network and everything, you have to lay down the cables, something as simple as that. You have to lay down the cable, you have to create your network segmentations, virtual LANs, and things of that sort, have switches and routers put in place, even before you say that my first servers can be spun up. Before starting the first server in your data center, you have to have this network in place, because that's the backbone of your infrastructure. How do you build a network in AWS public cloud? There's a service called Amazon Virtual Private Cloud, VPC. This allows you to create your network. You can define your subnets. Your subnets can be in different availability zone. Now, just try to relate the information we have understood so far. We have understood there are regions. So in a region, I have chosen, let's say, Mumbai. Now I want to create a network in that region, but where should I define the subnets? Which all availability zones should I use? So I can, let's say, for example, in Mumbai, there are 3 regions. So I can decide that, let's say, all of my, what do you call it? I will have 3 subnets, and one of it will be a production subnet, which will lie in availability zone 1, or in fact, and then the other one should lie in availability zone 2, and the third one in availability zone 3, right? So I'm defining my networks, okay, the subnets in different data center. These are physically set apart, right? So that's the power of cloud, wherein you are able to lay down, if I have to talk in the real terms of and comparing it with laying down your LAN cables, I'm actually laying down my network in different data centers, right? Provision a logically isolated section of your Amazon Web Services. Now once you have created this network, you can start turning on your services. You can start your VMs, you can start your platform services and everything, right? And again, I forgot to mention, this service is free of cost. Of course, there are charges like data egress, it's like data out. Whatever gets downloaded from the cloud is chargeable in the public cloud world. So apart from that, there is no charge for creating your network. Then domain name service. If you want your every service is eventually identified by the IP, right? When you want to access an infrastructure on the network, you have to know the IP, but that's not a friendly name. So we know the purpose of a domain name service. It helps you resolve a friendly name into an IP, and both ways actually. So let's say if my website is abc.com and is residing on some server with some IP, I need not worry about that. I can create a domain name for that and have all of this implemented through a domain name service called Amazon's Route 53. Route 53 is nothing but your domain name service. It's a reliable, cost-effective way of allowing your end users to connect your internet application, not just the internet application, but your internal application also. You can create your private zones so that you can have your host names or domain names resolved to certain IPs. So again, no upfront investment, and you have your domain name service up and running. Direct connectivity, private connectivity, how do you achieve that? Like I mentioned some time back, enterprises, for compliance reasons, for security reasons, do not want their connectivity to the AWS platform over internet. So they establish a direct connectivity with the AWS infrastructure, and that service is called AWS Direct Connect. So you'll have to contact the telecom provider, like in Airtel or Sifi you have in Mumbai, you have GPX, you have to contact them, and they will provision this connectivity in between the AWS and your network. Content distribution network and media streaming, as I mentioned earlier, a fast, highly secure and programmable content delivery network. The purpose of it is cache the objects, web pages, media and videos closer to the user. So as I mentioned, now in India there are close to 10 or 11 point of presence. So if my infrastructure is hosted in Mumbai and somebody is trying to access my page or a video on my page from Delhi, the traffic will not be routed through Mumbai. In fact, I mean, the content and all will be accessed from a point of presence in Delhi itself, which means the streaming or downloading of the objects or loading of the page will be faster, which otherwise would have caused some delay, because the traffic has to all the way come to Mumbai region, get resolved, and then address the request. Okay, so that's what a cloud front is. So let's see, where have we reached on the architectural front. We had constructed our account, IAM credentials. We chose a region. We created an availability, not created, sorry. We chose an availability zone. And now I have created a network, VPC, and I have chosen to, have my public subnet and private subnet in the same availability zone. I can also have this in different availability zone, right? But just to make it simple, I have chosen a single availability zone with two subnet. Public subnet is where my internet facing server will be placed, and private subnet is where my database or my critical information application server would be hosted, right? S3 bucket, this is something which we have not yet covered, so I'll skip it for the moment. But S3 bucket is also a service wherein I will be storing all my files, media files, images, and things of that sort. We spoke about Route 53. Internet users, when they put abc.com in the address bar, the Route 53 will do the resolution and it will resolve it into an IP. Okay, and then we can also use a content distribution. So let's say if the user is accessing a media file, instead of going all the way to the server, it will be addressed, it will be provided to the user through the content distribution network called AWS CloudFront. Right, so that's where we have reached on the architectural front. What are the storage devices? Disk storage. For every server, you need disk to be attached to it so that you can install your operating system first of all, and then you can go ahead to install your application. You can store your application related data. So what is the disk storage called in AWS? It's called Elastic Block Storage, EBS. It's a persistent local storage, and it is used for your relational databases, for any sort of your relational or NoSQL databases. You can run your data warehousing, you can install your application, make it a web server, app server, or DB server, whatever you want. You just have to attach this disk, install. It's like pretty much like your laptop. Your laptop has a disk attached to it. So this is same. Now there are various types. There are magnetic disks, there are general purpose SSD disks. There are also throughput optimized. Let's say an application or a database requires very high IOPS, which is input output per second. Then you can attach a throughput optimized disk as well, so that you can achieve higher IOPS. Right, so a disk is nothing but and called as elastic block storage in AWS. Then you have object storage. Where is it that you need an object storage? Wherever you want to store a readable data, not a write data, right? A readable data like your PDF file or your images for your website, or your, let's say, your videos, which will be embedded on your website. So all of this information is readable information. If you want to edit it, you have to download, make changes, and then upload it back. It's pretty much like your storage, your Google Drive, or your you have OneDrive, where you store your information for read purpose or sharing purpose. So and it's called object storage. Okay, so what is the object storage called in AWS? It is called a simple storage service called S3. And it's popularly known as S3. S3 is one of the first services that AWS had released when they started the public cloud platform. Right, it's the oldest when it comes to age of all the services. Okay, so it's a very durable platform, highly scalable. You don't have to worry about maintaining the infrastructure for storing your database. You don't have to worry about your disk going corrupt and hence losing the information. Nothing of that sort. It provides you 11 nines of durability. We call it like that in industry. 11.9 means 99.9999 up to 9 times, right? So 11 nines of durability is what you can achieve through an S3. Then archiving, some companies have this compliance requirements, like for example hospitals, they have a compliance requirement that the patient record has to be stored with you for at least 7 years, right? It is part of the audit, it is part of the compliance requirements. Now the cost of storage is very high. So what do companies do to comply to such kind of requirements? They store the data on tape, the tape that we have usually seen, that we load in the VCR. Similarly, there are tapes, because that's the cheapest medium to store data. Now, a similar to a tape, what is it that is available on AWS at a very low cost? It's called Glacier. So S3 Glacier is nothing but a service wherein you store your information, which is not going to be accessed for a long period of time and needs to be stored and saved for a long duration, typically in years and months and years actually. So it's called Glacier. It is again an affordable but a long-term storage class, and it replaces your tape for archiving, and it is typically used for adhering to compliance requirements or regulatory requirements. Your BFSI companies, your banking and finance, your health industry is has to comply to a lot of requirements of this type. So they use this service called Glacier. Now let's see what is it that we have achieved on the architecture. But before that, let me cover these services so that you can build the complete architecture as well. We are a little ahead of time. I mean, sorry, we have spilled over the time for this section. Now, I mean, we have spoken about network. I mean, we started by discussing account, users, network, content distribution, object storage. We talk about all of it. Where is my server? I mean, where is it that I'm going to install my application? So a server, which is also called infrastructure as a service, is called Elastic Compute Cloud in AWS. It's, the abbreviation is EC2, Elastic Compute Cloud. This is the most used service on public cloud, not just AWS. Any public cloud platform, the virtual machine or the server service that they provide is the one which is highest consumed. And I mean, of course, both in terms of money, the consumption of services is highest for servers. Okay, because that's where you install your application. By the way, just to mention, there are PaaS platforms also, which is called platform as service, and there are services called as serverless as well, which we are going to cover very soon. So this is a secure, a resizable compute capacity in the cloud. You can resize this with me, not just I mean vertically, but also horizontally. You can, let's say, if you want to upgrade from a 2-core 4 GB to 4-core 16 GB, go choose the right size of image and spin up a new server, and within few minutes your upgraded instance will be available. On the same hand, if you want to run two servers for load balancing perspective and availability perspective, but all of a sudden there's a surge in the traffic, those two servers can immediately be spun up to 10 servers to handle that entire load. So that kind of elasticity options are available in Elastic Compute Cloud. What is this? This is nothing but your server. Abbreviation is EC2. A managed server. So we're talking about a server wherein, let's say, if I'm a programmer, not let's not say a programmer. Let's say I'm a WordPress administrator. I build site on WordPress. I am expert in WordPress, but I do not understand what the server is, how to build a network, then create a server, attach storage to it, install my application. I do not know all of this. All I know is access my server, go to my cPanel, and start doing my WordPress job. So there is a managed server also, managed service I should rather call it. And this is something where in the demo also we are going to cover this. It's called Light Sail, very popular amongst these website developers and administrators. All it does is it bundles all the service of server, storage, database, networking at a very low and predictable price. You'll be amazed to see that an instance is available for just $3 a month, right? So Light Sail is a service which is very popular in developers. They just go ahead, spin that up, and access it and start doing their development job. Again, this is a platform service. As I said, server is infrastructure as a service, wherein you get an infrastructure, you manage it and own it. This is a platform as a service, wherein the infrastructure and availability management of that is taken care by AWS, and you only use it as a service. Okay, so we will see that in a demo. What is a serverless? So I do not want to log in onto a server, write my code, and do things of that sort. I do not. I don't understand, neither is it that I have any intention to learn or understand server, storage, networking, or anything. All I know is write a code, right? So in a Lambda is nothing but a serverless service wherein all you have to do is upload your code and run it, right? It could be a logical, it could be a code that can run due to occurrence of an event, right? Let's say, for example, if somebody loads an S3 bucket, then it should trigger a Lambda service which will convert that S3, that particular image into a thumbnail and attach it to my profile or something. So how do I achieve this automation? How do I write codes and only codes and not worry about the infrastructure or the platform on which it is going to run? Popular programming language like Python and Java and things of that sort, everything is supported, which gives the developers the power to write, focus and write their code and not worry about execution. So you're not charged for any. So you see, in these services, as long as it is running, it is chargeable. But this particular service, the beauty of this service is that you do not pay until and unless the code is running. So let's say if an event occurs and it executes your code, you will pay for that particular duration for which the code was running, and at the same time for the amount of memory that was used, right? The RAM that was used. So that's the beauty of it. And developers love it because all they have to do is write code and not worry about anything. Then there's a service called managed database. So again, the same problem with database is that more than the database, we have to invest a lot of time in administrative overhead of managing the server, uptime of that server, then patching of the operating system, patching of the database, creating, managing, and maintaining the backup of the database. There's a lot of administrative overheads. Now, AWS provides a managed database service called Relational Database Service (RDS), wherein you just have to access the DB, create your DB instances within that. Let's say you want to create 5 databases for your 5 different line of business or 5 different departments. Just go access the database and create the database instances within that. You don't have to wait for a server access, and then let's say, all the administrative overheads, everything is taken away, including the backups. Backups are automated. You can store it to any second with the transaction being restored. There are a lot of such features without the overhead of managing it. Typically what happens is my database and everything was up and running, but there was some problem, probably a security flaw also in the operating system. Now that has led to compromise of my overall database as well. Now who is it that going to manage that server, the operating system, the security of that, the backup of everything that is running on top of the server? You don't have to worry about anything of that sort. Just turn on the relational database service, RDS service, and start working as a database administrator. So that's the power of cloud. You get infrastructure as a service, you get platform as a service to play around. And as I said, create your infrastructure, deploy it anywhere in the world, go global in minutes, and serve the idea that you have in your mind. So that's the relational database. Now let's see what the architecture is. We covered about account, we created IAM, we chose a region, we chose an availability zone of our choice, we created 2 network, public and private subnet, and now I have my server. So this is my EC2 app server. This is hosting my web and application logic. This is nothing but your EBS, your block storage, which is connected to it. One of this is my OS disk, and the second one is my data disk, wherein my application is installed and my application related data is stored. Then I have created a managed database, because you see, I don't want my client to be worried about availability of the database, because that's a very critical component. So I have chosen a managed database. The connectivity between them happens through rules called network access control list, NACL, and with the help of security groups. So you, with the help of this, you can allow, disallow traffic. You can define which port is open for a particular service, and define the IPs that can traffic over for which can be allowed. So a lot of such rules can be created. Then now internet user, whenever they try to access the application, Route 53 will do the domain name resolution, provide the IP, and so that the app server can respond to the request. Now my users have started complaining that the website performance is slow, it is loading slow. So what I do is I remove all the media and the objects and store it in an object storage. I connected with a CloudFront storage, which is your CDN service, and now the performance has improved because the frequently accessed data is now available closer to the internet user through the point of presence, or call it, we can also call it edge location. Okay, so that's how the architecture is built. I repeat, and I've added a disclaimer over here that this is just to illustrate how some of the building blocks can be put together to achieve a two-tier application. There are many components that needs to be added, both from the availability, fault tolerance perspective, security perspective, and many more things. Okay, but I hope you have understood some of the basic services of AWS and how all of this can be put together to create a two-tier application. Now, the most important thing, or the most important takeaway of this particular section is, you must have seen that there are many services which is available for free. You have not invested anything upfront, and you are simply able to spin it up anytime on demand through a self-serving portal, and you'll be paying for it only for the duration for which you'll be using this. Okay, so that's the power of platform. It treats a student and an enterprise equally. You have a fantastic idea, go ahead, create your account in AWS and start building it without worrying about investing and creating an infrastructure to host your idea. Okay, so just would like to share more that AWS is a leader in the public cloud domain. They are a leader in the Magic Quadrant. You can see they sit right here on the top, followed by Microsoft and Google, and then there are other players like Alibaba, Oracle, and IBM, who are providing infrastructure as a service and as a public cloud provider. They provide you pay as you go model. We discussed this, and they have 175 fully featured services that is listed, and they have made cost reduction multiple times in the past few years, right? So we use the term economy of scale. As more and more people start using the public cloud platform, the cost for running this public cloud platform gets divided in between those consumers, and hence the price keeps going down. So let's say an investment of 100 rupees, if divided between 10, everybody has to bear the cost of 10 rupees. But if you have 100 such servers, all the users will be paying only a rupee for using these services. So the economy of scale is one of the ideology wherein AWS is trying to pass on the benefit to their clients so that they can access a state of art infrastructure globally with a very less cost, and in fact I should say with no upfront investment. Okay, so these are some of the logos, some of the use cases. This is a finance related logo. They are collecting and analyzing billions of brokerage transactions. So this is all available on the public site. Coursera is a very famous platform for your as a learning module. Most of the popular universities have their courses hosted on this platform. This is completely running on AWS. Okay, similarly Airbnb, you must have heard of it. The ones who help you rent house or accommodations, they are running completely on AWS with just handful of engineers. For an infrastructure of this size and type, because they are on public cloud platform, they are automating it. They have modernized their application in such a way that with just handful of servers, they are able to provide a seamless service to all their customers without any glitch in an automated fashion, right? Similarly, some of the other use cases, Expedia, Intuit, and then Shell, they're all using AWS platform. So who doesn't know Formula One? We all know this. Formula One uses AWS cloud platform for there are billions and billions of metrics. You see an F1 car has multiple sensors. So, and it's now called an IoT. It's an internet device, internet connected device, and it's IoT means Internet of Things, which means this is a device which is connected over the internet, and it keeps emitting a huge amount of telemetric information. Let's say the speed, the temperature of the engine, the various such factors. So all of this millions and millions of data points, right from the cockpit to every other sensor of this F1, is streamed live to the F1 team, and then basis the analysis, combining it with the historical data, they are able to take decisions. They are able to strategize the race in a real time, right? So that's how F1 has been using AWS public cloud platform. I would really request all of you to go ahead and read these case studies, these white papers, that will motivate you. In fact, that will give you a lot of ideas. It will motivate you to use the public cloud platform and achieve your ideas, implement your ideas, and see it in real. Okay, let's get into a live demo. I'm sorry, I'll have to change this over here. I am going to show you how to host a WordPress website using the past service that I showed, the light sale, and then I'll also show you a chatbot, okay, a sample, a demo chatbot. So let's get. So this is your AWS cloud platform. As I had mentioned, these are the regions where you can choose any of the regions. So let's say if my users are in US East, North Virginia, I can choose this region and start creating my infrastructure over here. Similarly, I can go to any of my regions depending upon my choice and my preferences, and also sometimes due to cost. So if every region have a different cost for each of the services, right? And I would like to show one thing. So you can create a free tier account of. I would, instead of talking more about it, I would request you to go ahead and read what a free tier account is. There are tons of services that you can use without paying even a single cent to AWS, because they fall under free tier for 12 months. You see, I've been using this since April, and I have not paid even a single rupee to AWS, and I've been doing my demos and some of my other tasks on AWS public cloud platform. All I have to do is take care that after I create the service, after my purpose is served, I go ahead and delete it. If you keep it running for a longer duration, if it crosses the free tier time frame, then yes, the billing will start applying to your consumption. Okay, so let's just check a light sale. Right, you can use this, let's say, when you're up in your upcoming event, your tech fest. If you want to host a microsite for your tech fest promotion, you can simply use this service. In few minutes, or in fact even less than that, you will see an instance up and running. Now you see, I mean, I'm a developer. Okay, I'm a developer, and I do not know anything about servers. I do not know anything about databases, networking, storage, or backup. The snapshot is nothing but your backup. How do I deal with it? I go to Lightsail, I create an instance, I choose a region of my choice. So it is allowing me, you see right now the light sale service is available only in this region. I go ahead to use Mumbai region. I can go ahead to change the availability zone as well. You see there is zone A, B, and C. Mumbai has 3 regions. Let it go to zone A. What platform do I want to use? A Windows platform or a Linux Ubuntu platform? Let me use that. Now you see I have the option to select application plus OS or just the OS. Let's say I'm aware about hosting my application, how to install my application. I would go ahead only with OS. Or let's say I do not know that, I just know WordPress. I want a server which comes pre-installed with WordPress application. I will go ahead with this. I'll choose WordPress. You see, I'll keep all the default. You see what's the price over here? The first one, by the way, is free, and every month you're going to pay only 3.5 USD for a server which is of size 512 GB, one vCPU, and a 20 GB disk, which is SSD. Okay, and this is the data transfer cost. Remember, I mentioned sometime back that one of the other fee that a public cloud provide, not just AWS, every public cloud provider charges you is for the data out. So let's say anything that goes out from your AWS account, from your AWS network towards the internet, is counted as a download charges. So here 512 GB of data download is included, which will give you a monthly bill of just $3.5. So let's select this one. I'll keep all the default and simply go ahead and create an instance. So you see now it is provisioning. It just took me 30 seconds to choose the instance of my type, the platform of my type in terms of OS as well as application. And now all I have done is created it, and this is running. Okay, so let's just wait for a few seconds. Meanwhile, I'll just open another console so that we can also start talking about. Okay, see, it's provision, it's up and running. Let's click over here and get the information about my instance. So here is my instance. I can do an SSH, right? SSH is directly connecting to your instances. Okay, if the instance just started up, try again in a minute. So maybe the provisioning is still happening in the backend. So let's give it some more time. Meanwhile, I'll just take you to the console here as well. So you can see this console. These are the set of services that is available for compute. your containerization, which is microservices, your storage, host of services, various multiple options for your databases. This is your RDS, this is your NoSQL, this is your in-memory database, your data warehouse solutions, and things of that sort. Okay, migration and data transfer services, network. We spoke about VPC and CloudFront and Route 53. Developer tools for your automation of your software build and commit. uh, so we call it CI/CD integration, continuous integration and deployment, right? So you see there are services for your robotics, then you have analytical services, internet of things, machine learning, a lot of services. They are one of the leaders here. They have tons of services on machine learning front. You can create your own workspace like a desktop, your Windows 10 or something, business application, your email services, then your remote collaboration services like a Chime, which is equal to your Hangout services. So you see there are tons of services that is made available. Now as a user, as I said, public cloud platform AWS treats a student as well as enterprise equally. As a student, if I log in and create my account, I have the option to use any of these services without having invested anything and without having worry about the manageability of any of the underlying infrastructure. So host of services, tons of options available to help build the idea that I have. So let's see, this must be available for SSH. Great, it's connecting. Awesome. I am in my server now. Let's see what's the output of this. Here is the public subnet. Let's open a page and see what is this hosting. Oh, great. My first blog on WordPress is already live. I mean, if I am a WordPress developer, I'll go ahead and access my what do you call it, the relevant consoles, the panels, and start editing this and creating my own blog hosted on my own infrastructure, right? So this is what you see. I've simply input the IPs, and my page is up and live. So you can use this for your next, let's say your tech fest or something. If you're creating an event, build a microsite with just $3.5 a month, and have it hosted on AWS in a secure fashion. Okay. Now that's one demo. So what is it that we were able to understand? Okay, and most important thing, after doing any of the activity, when you create your own account and when you're doing any of the activities, ensure that you terminate the services. Otherwise, you'll have to bear the cost of it. Fortunately, for this particular demo, I have to pay nothing for the first month as you had seen. But yes, for still, I would go ahead as a practice to stop this. Okay. Now I have the option to delete this, and I should delete it because I should do all the cleanup. Okay, it will. Okay, maybe the shutdown is still happening. Okay, once that is done, we'll delete it. I will come back to this page. You cannot delete while it is in transition. Okay, still, I mean, the shutdown is still in transition. We'll delete it later on. Let's go to the next demo when we will create a chatbot, which is available as a sample on the Lex console. So you see what is this Lex? You can use this for building conversational interfaces for voice as well as text. Your Alexa can be very easily integrated to Lex, and you can have a voice enabled chatbot assistant. Okay, you can have this at your next Tech Fest booth, wherein at the inquiry counter of all the other volunteers, one of the volunteer can be an Alexa answering and addressing the queries of all the visitors and attendees of your Tech Fest, right? Please use that. Now let's say, I mean, I will not create anything of my own. I will simply pick up something, let's say booking a trip or ordering a flower. So we have to mention over here because we have to abide by the Children's Online Privacy Protection Act. So I have to give a confirmation that this does not violate anything of that, and the subject is friendly towards children as well, right? So it did not even take me 5 seconds because I mean, of course, I am choosing a pre-built solution, but when my intents and things of that sort is available, I can go ahead and create it. Even before, let me show one more thing to you. Okay, let me just delete this. Let's just create one more. Okay, so before that, let me explain what are the components of a chatbot. This is what I missed. So intent is the subject or the topic or the use case that you're trying to serve. So here in this case, let's say intent is going to be order flowers. Utterances is what the user inputs in your chatbot. So let's say, for example, I here you can see I'd like to book a flower, and then what you get in response from the chatbot is called prompt. Okay, so chatbot, like over here you see the utterances from the user is I'd like to order flowers, and the chatbot has responded what kind. And then there are other slots, which means the data and the user must provide to fulfill the intent, to proceed further with the intent, to complete that particular conversational transaction. You have to provide that input, which is called a slot. And then you have prompts. Again, in return, it will give you prompt and work towards fulfillment of your request, right? As I said, I'm going to use a chatbot which is already built, right? So this, once you have built it, you have the option to integrate it, let's say, with your Facebook web page or any of your other application. But here I'm not going to demonstrate integration with the application. I'm only going to show you that this particular what do you call it, chatbot is up and running within few minutes. Now all I have to do is just input the sample utterances. You see the utterances that I have created is over here. I will be using these utterances and try to order some flowers. Now you have to understand one thing about chatbot or any such model. Now this is something which is emulating a human behavior, which means you have to first start with some basic utterances, prompts, and responses. And then as you come across more and more users using your chatbot, you'll start to learn and do a modeling of your chatbot so that it starts responding to other utterances other than just these two. So right now in the demo, I will choose only these two. But but I just wanted to inform you that a chatbot, a full-fledged, a mature chatbot, doesn't happen in one attempt. You have to feed in with a lot of model data so that you can model it, train it to respond to various kind of utterances from the users. So let's create one. We already have it. We are in the testing console. Let's say I would like to order some flowers. Let's see what's the response. What type of flowers? I would say, what type can I put? um could be roses. What day do you want the roses to be picked up? Let's say I want this to be picked up on a Monday. Now it is asking me pick up the rose at what time on this. So it has chosen the nearest date of 25th and asking me what time do you want. Let's say if I want it at 3 p.m. Okay, so now the response is your roses will be ready for pickup by 15 hours, which is 3 p.m. on 25th of May, which is Monday. Does this sound okay to you? I would say yes. And now my order is ready. Okay, the order flower is ready for fulfillment. So this is the detail of your order. Okay, so here you have just seen that this I've just picked up a template of ordering a rose, and I have created this test chatbot. As I said, in your next tech fest, your event, you can, apart from your other volunteers, one of your volunteers should be an Alexa. This Lex chatbot, it can also be voice enabled, and let all the inquiries and utterances and all be served through that. It's going to be a major attraction at your inquiry desk. I'm very sure about that. Okay, this can be published. When you try to publish, I'm not going to publish it, by the way. I just want to show it to you what options it gives you. Let's wait. Okay, meanwhile, let me just delete my instance before I forget it. Right, so now I don't have any instances running over here. So you see what it is showing you. It is providing you a connection information so that you can connect to your mobile application. You can integrate it with the mobile hub service of AWS, which is a platform through which you can do effective development of your Android and iOS applications. Then you can also deploy your bot service to some of the other messaging services like a Facebook Messenger a Slack channel or a Twilio or a Kick. Okay, so these are the various channels and methods to integrate it, which is what we are not covering in this. Okay, so that was about the demo. One second. Right, so this was the demo that we did. What is it that we should infer from this demonstration? Innovate faster. Before you start implementing your idea, you don't have to worry about investing in infrastructure. I'm repeating it again because this is the biggest advantage. You see, when you have an idea and if you have to wait for a long period to start working on it, by the time probably you lose the interest in that idea, all your enthusiasm gets lost, and in fact I should say it gets killed. So innovation requires immediate action. You get an idea, go onto the AWS console, start implementing it, get your team together, and innovate your next idea and keep it ready. Okay. So innovation is faster. You can go global in any minute. You saw on the console, I can choose any of the services in any of the region. Okay. So that is how you can go global in global any minute. No overhead of infrastructure provisioning and management. We saw that I don't have to do any infrastructure provisioning and management. My network and all, everything was created within few seconds, within 30 seconds. Cost of failure is low. Let's say the chatbot that I created, if this was to be created on premise, first of all I would have paid rent for an infrastructure server, procured the licenses, or probably I would have gone for an open source to cut down the cost. And then when I, let's say my chatbot did not work, I did not get enough traction, I was not able to use it, what do I do with it now? I have to pay for the infrastructure which I had rented out. But here the cost of failure is low. The moment I realize my infrastructure, I mean, sorry, my idea is not working, let's go ahead and delete everything. I don't have to pay anything. In fact, you'll be surprised and you should be happy to know that there are many companies who have started their infrastructure. They have built their application on public cloud platform, and trust me when I say that they have been able to keep the uh, uh, cost of their infrastructure very low because of the free tier itself. So very intelligently they have scheduled their services. They shut it down at times when it is not required. In a very optimal fashion, they have used the first year of free tier and kept the cost of their entire startup so low on the infrastructure front that gives them a lot of leverage. The finance that is required in IT was they were able to route it towards marketing, towards business development, and things of that sort. And let's say if the startup fails or if the idea fails, sorry, I don't want to use the word startup again and again, but then I'm only trying to relate it with the innovators. Okay, that is what I want to mean. The innovators, for the innovators, it's not a problem because the cost of failure is so low, and that encourages them to do more and more of experimentation. Okay, before we go ahead with the career outlook, I have some questions here. We'll take those questions and then we'll understand the AWS career outlooks. Okay, I have a question from Preetham Yadav. I noticed there was a machine learning services available. I have a project in which I have to implement an ML model for real-time data, but it has to be implemented on very low-end devices. So that's a very good question. See, so you see, for your machine learning, first of all, I'm not a machine learning expert, but I will give you two perspective of looking at a public cloud platform. Probably you will pull in a lot of open source platforms which is required for your AI and ML, and I'm very sure there are a lot of, I mean, most of the platforms and the tools that is required for your AI ML implementation, model learning and modeling are available as an open source. You can choose an instance and install on top of it. You can choose a size of any type, let's say a 2 core or 4 GB or whichever is the minimum infrastructure. Or even better, you can go ahead and use the already available services of AWS. I will not be able to give much detail on what each of the AIML services does is, but yes, I can give a guarantee that if you know the size of the infrastructure, you can do your experimentation, you can do your implementation with the least possible cost. Take the advantage of the free tier, choose an instance which is free tier eligible. Of course, it has to be of a size that is recommended for your modeling tools and the AI ML tools. You can go ahead and install it on an instance, or you can go ahead and use the ready-made available services of AI ML, whichever suits you the best. But mind you, the only thing that you need to take care is understand the pricing model of each of these services and then take a decision. That's the only advice I'd like to give. Can I use any AWS? I have okay. Preetham has another question. Can I use any AWS service to compute the that data and return the results? Kind of like an API. So you see, there are you have to understand a little more about how various AWS services can be put together to achieve a use case. 100% of the things can be implemented on a server like in EC2 what we saw, because you see right now if I remove the public cloud fundamental of PaaS services, platform as a service or software as a service, everything at the end is running on a server. You need a server, you install an operating system, you install the tools of your choice, and then you start running it. So anything can run on it. You can also have your API gateway implemented on a server, but then you have to better understand the available services. API gateway is available as a service, so you don't have to create and manage on your own on an operating system or on your EC2. So understand your first define your use case, try to relate the various services available on AWS which can serve each of the block of your use case, and then put together to achieve the final result. So you'll have to do some reading, understanding of the various services. In fact, I would say that on AWS there are reference architectures, tons of reference architectures. Read those reference architectures so that to understand how each of these component connect with each other to serve a particular use case. That would be the best way to design an architecture or a solution pipeline for your use case of the AI and ML. Okay, I hope I have answered that. The next question is from Anmol Chauhan. For data access, speed, and security, wouldn't a private physical server be more reliable? So first of all, let me put it in this way. Having a private physical server doesn't guarantee you performance or speed. It is many other components. The connectivity, right? When you're talking about speed, first of all, the connectivity at the user end. If I am accessing your application and my internet itself is slow, that is one thing. But we are not factoring about that. We are factoring about, as a application provider, how can I improve my application. Now you see on AWS cloud, okay, you can go global anywhere, number one. Second, you have options with multiple, more than two multiple edge locations, so that you can have your data, your application cached nearer to your user. At the same time, you have the option to play between a hard disk or a throughput optimized, I mean general purpose, or a provisioned IOPS kind of instances, which mean you can choose in between the various disk type to achieve certain performance. You see, your disk also plays a very critical role in your application's performance, right? The second thing is what do you call it? Uh, the hardware performance. Okay, now AWS will always provide you the latest and state of the art infrastructure, okay, from the hardware perspective as well as from the hypervisor perspective. Now when you are hosting a particular application in a private environment, once you have invested in a hardware, you are invested for 3 years or 5 years. Initially when you had sized that, it is good, it is giving you good performance, but as the user base increases, there'll be more and more users coming to your application. There'll be a huge amount of data read and write happening on it. Now you don't have an option, because you've already invested heavily for 3 and 5 years. The only option that would be left with you is to upgrade that particular server. Are you ready? Do you have the pocket to again invest into a fresh hardware because your business requirements have changed? Absolutely not. That is going to hurt your business and your pocket, right? But with cloud, when we are talking about access, speed, security, the infrastructure is all completely taken care by the public cloud provider. Talking about security, I'd like to add one more point. The security of your infrastructure is completely taken care by AWS public cloud. You don't have to worry about the physical security, security of your hardware, and things of that sort. Think about a DDoS attack happening on your underlying network. AWS has designed the infrastructure to absorb massive amount of distributed denial of service attacks, and keep you away from unavailability of your infrastructure. So everything is taken care over there. On top of that, of course, the security has to be taken care by you. But yes, security, your speed and accessibility, everything is something which is managed. You don't have to worry about it, and focus on that. And going back to the example of upgrading your infrastructure from time to time in order to serve use cases, or in order to serve, let's say, increasing demand of your application, it's only a matter of few minutes. Take the snapshot, spin up a new server of a larger size, and start serving a high traffic, or even better, from 2 server scale up to 100 server and serve a dynamic what do you call it, web traffic. This is the speed, this is the availability of infrastructure which you cannot provide on premise. Okay, so that's for the question from Anmol. Then I have a question from Nirmit. Can tell me what do you mean by platform as a service and software as a service? Very good. I typically intended not to get into that because of time. But then yes, I will answer that question. Infrastructure as a service is when you create a machine and you start managing the machine, the operating system, the disk and network and everything connected to that. You're talking about infrastructure as a service. We spoke about EC2. In an EC2, the provisioning is, let me take you to the console so that you better understand. It's better to show you in. So you see EC2, why is it called as an infrastructure as a service? So here you see, when I want to host my application, of course I need a what do you call, an operating system. Now where do I get that operating system? It has to be a server. So over here, right from the server up to the operating system, the connectivity of that, and then the performance of that, everything is something which is managed by it. I have to manage the operating system patching, I have to manage the backup of that particular instance and everything. And that is why it is called as an infrastructure as a service. The public cloud provider is providing you as an infrastructure, okay, and you have to now manage from there onwards. The underlying infrastructure is not your problem, but yes, from here onwards, OS, patching, backup, availability of it, tolerance, fault tolerance of it, everything is your responsibility, right? I will not take you through the entire demo, but I'll just quickly show you some of the images that is available. So you see, I wanted to run an application and I chose that, let's say I want a Red Hat application. I will select Red Hat operating system. You go back to the demo of the light sail. There I was just given some standard images, I turn it on and my server was up and running. I just had to choose the package. Now I have to choose, I have to define how many core, how many memory and everything, and then create an instance. This here I am creating an infrastructure which is a server for my own self, and I am going to own everything about that. That is infrastructure as a service. Okay, including the security, availability, and everything. Platform as a service is, let's say I do not want the overhead of creating, managing, and maintaining a server. Okay, which means the operating system, the backup of it, fault tolerance, scalability of it. I do not want to manage anything because I am a database administrator. I am a developer. I do not understand server administration. I do not understand network administration, or I do not have the skill set to do a patching of the server. Why should I put in my time? I should be giving all my time towards database administration or my development. So I choose a platform as a service. Here, RDS, as we discussed, I will quickly show you that. RDS is not all these services you see. This is a platform as a service. The underlying operating system, availability of the application, what do you call it, the infrastructure, server, networking, storage, backup, everything is being taken care by AWS. All you have to do is create the service. You will get an endpoint URL like any other URL, a DNS URL. Access it and start doing your DB activities, right? So here, from here, you can create a database. You don't have to create any instance, right? So that's what a platform as a service is. Your RDS is your platform as a service. So differences in IaaS, operating system and everything on top of that is managed by you. In platform as service, no need to manage anything of the operating system, backup, availability, and maintenance and management. You create your database and start using it. Now, software as a service is, take example of your email service, your Gmail. Has any one of us written that email program? Absolutely not. Are we managing the infrastructure to host that email program? Absolutely not. All we did is created an account and we are using it. Your Facebook account is a SaaS service. It's a social media SaaS service. Your email accounts is a SaaS solution. Similarly, in the cloud world, in the enterprise world, SaaS solutions are available. You can think of, let me show you a marketplace of AWS. I'll show you a lot of SaaS services. What is the advantage of that? I do not want to do anything, not even the development of that particular service. I just want to turn it on for my use case and start using it. A typical example of that can be, let's say, a security service called WAF. A web service is a security service which is used to protect your application. We have these OSI layers, layer 1 to layer 7. I want to protect my application from malwares and bots and things of that sort. Now, instead of installing an operating system on a server, then installing the security solution on top of it, then configuring it, worrying about its availability, backup, and things of that sort, manage, hire a security administrator, server administrator, and then a monitoring team to ensure that the service is up and running all the time. All I do is I will subscribe to a software as a service and add all my applications in it. Now it is the overhead that, I mean, Fortinet over here in this case, or a Barracuda or a Checkpoint in this case, will be managing this entire infrastructure and the service. All I have to do is I have to subscribe. Any service that wherein you subscribe as a software, you create an email subscription. Similarly, you can create a security subscription. Is nothing but your SaaS service. Okay, I'll have to go a little fast. Okay, so that was a query from Nirmit, and the next question is with Sahil. Is AWS killing Hadoop? Your thoughts on it? Okay, first of all, Hadoop and AWS are totally different platform. Here, Hadoop is your big data solution. It's your analytics, your data lake analytics solution. AWS provides you a platform wherein a completely managed platform wherein you can run your Hadoop clusters, right? I'll show you EMR over here. It's totally different. You see, AWS is a infrastructure provider. It's a public cloud provider wherein you can also run your Hadoop infrastructure, not a problem. You see over here, EMR, what does it say? Let's just read it so that I can give you confidence that these are totally two different things. In fact, on public cloud platform, implementing a data lake, implementing a big data has become far easier, because for a data lake, for a big data kind of solution, the size of the infrastructure is really huge, which means the upfront investment one has to do is also going to be huge. Second thing is, these are all long running projects. You have to invest a lot of time first in implementing the infra and then implementing your use case before you really start getting a return on your investment. Big data and things of this sort are implemented so that you can get in-depth business related analysis, your business intelligence and things of that sort, but the return on investment is very slow. Here you can accelerate your return on investment. You can create, actually, you see, Elastic MapReduce is a web service that enables to implement your your research, your data analysis and everything, and you can create your clusters over here. So this is nothing but your big data solution. So it's totally different, cannot be compared. I have again a question from Sahil Pathak. Okay, that was Sahil Sati, and now I have a question from Sahil Pathak. Which are the different layers that define the cloud architecture? Okay, so I will restrict it to the layers that we spoke, but let me show you a diagram. Okay, this is a very good diagram. Typically I talk about it, but in the interest of time I didn't want to talk about it. But since you brought this question, you see, I mean, I am trying to cover two things in the same question. Typically I'm seeing, see, you have regions, availability zones and edge locations that we discussed. That's the data center, the geographical construct and the data center construct, wherein you will have all your hardware and everything, your AWS global infrastructure implemented. On top of it, they will this is all through your hypervisor. Basically there will be a hypervisor, which is a virtualization layer, and then all your services, you see, your compute and storage and database, these are the services that we are what do you call it, this is there in the backend, the software, nothing but the virtualization thing that is being implemented. So these are the layers. I mean, not a very good diagram to take your to answer your question, but I purposefully picked this thing so that you can also parallelly see that how the security works. Security of all this underlying infrastructure is with AWS, and anything that is running on top of the AWS public cloud platform is the responsibility of the customer. But yes, to answer your question, these are the blocks. In fact, even better and easier to remember, you go back to our first slide wherein we were trying to differentiate between a data center and the public cloud. The building blocks are same. You use the same server, storage, networking components, but yes, these are all modern state-of-the-art infrastructure. They constantly invest and upgrade the infrastructure so that you get the best speed, best performance, and best of the security, which is not possible on premise. Once you have investment, you have to live with it for 3 to 5 years. But here, AWS keeps inventing, keeps modernizing the underlying hardware infrastructure from time to time. Okay. I'll go back to the slide. I'll have to be a little more quick. I have a question from Yesh. How is AWS better than its competitors like IBM Cloud, Microsoft Azure, and Google? So you see, I spoke about the quadrant. AWS is already better. one of the first advantage that AWS has is that they were the early movers. They were the first to provide the AWS public cloud platform. I'm not saying they were the first to come up with the concept of public cloud, but they were the first to get the commercial benefit, launch the commercial solution of public cloud. So they have the advantage of being the early movers, which means they have seen more problems they have got better feedbacks from the users and customers, and they were able to develop the services to serve better use cases. If I have to really compare it, as a solutions architect, I have seen that all the public cloud platform eventually are turning out to be the same because they have the same set of services. It's just that they differentiate when it comes to their global construct. Let's say, for example, AWS has one region, Azure has three regions in Mumbai, I'm sorry, in India, but AWS has three availability zone in the same region, providing you a better fault tolerance. But Azure doesn't have any availability zone. They have the concept of availability zone, but not in India. They have just single standalone regions in India, three different regions. You have Pune, Mumbai, and Chennai, right? Then there is a difference in the way the pricing works. AWS, of course, I mean Azure, of course, has the advantage when it comes to Windows licensing, but then AWS also has its own Linux flavor, which uh, is available at a very very low cost. And then there are advantages. The host of services that they provide in terms of machine learning and things of that sort is really vast. So there are differences in terms of pricing, in terms of, as I said, the services and all of that. But that actually is not the real way of choosing a cloud platform. Anyone who's trying to use it now, the world is going multi-cloud. Nobody wants to put all their eggs in the same basket. People are using more than one cloud. They are using two cloud at least, depending upon the use cases. I would not want to call off any preferences for any of the public cloud platform. I'll restrict it to AWS. But yes, basis the use cases and various scenarios, people are public. Are multi-cloud right now. Okay, I'll have to rush a little bit. What are the advantages of private cloud over public cloud? So you go back to the first slide wherein we were trying to differentiate between the various components, the 5 points. A public cloud is something which gives you a pay-as-you-go model. There is no upfront investment. If you have to build your own private cloud, yes, you can achieve the features of it, but then eventually you have to invest upfront, right? And you have to keep investing as your requirement grows, as your business grows. That investment is something which is completely zero. There is no capital expenditure. There is no upfront investment. There is only operational expenditure. As you turn on, the operational expenditure of that is what you have to pay. That is one of the biggest differentiator of a public cloud platform, public versus a private. Okay, how do you secure data for transport in cloud? Yes, there are various ways. You can encrypt your data through a TLS. You can have your certificates implemented. Then you have to put across a layer of firewall. The VPC, the network that we created, right? We somewhere I had used a term called network access control list and security groups. That is where you allow, restrict, and certain IPs and certain ports. That is one way of securing your application and the data. The other is people add a layer of firewall, they add a layer of WAF. All these services are available as a service by AWS. So web application firewalls, and then your network access control list, your security groups, your encryption at rest. AWS provides you, allows you to encrypt your disk. It allows you to encrypt your snapshot or call it backup. So there are tons of such features available that you can use without even investing any upfront money in that. Security solutions, encryption solutions requires huge amount of investment. You have to procure hardware licenses and things of that sort when you want to implement it on premise. So that's how it works in security. That was a question from Rohit, and then I have a question from Ayush. Is it better than Hadoop? We covered it earlier. These are two different things. Hadoop is, in fact, can be implemented on AWS. Okay. Yes, Mehta. I mean, I have a lot of questions. I think I'll have to. Oh my God. I mean, I have a lot of questions. This is huge. I don't think I'll be able to address all of it. We just have 20 minutes left. I can give you one assurance. I will go through all of these questions. I promise you I will answer all of this question, and the CMI team will publish it to one of your to the coordinator, so that you can access it from there, or maybe we can publish a common link. Whichever is the easiest way, he will figure it out. But to be honest, practically it's not possible to address all of the queries. We just 20-25 minutes more. Let me cover the other section of the presentation, and then we will come back and we'll try to pick up one or two more questions. And then, as I said, as I promised, I will answer all of the question in writing and make sure that it is getting addressed. Okay, I'm really sorry for that. We don't have time. Career outlook. So you see, this is a report in 2018 by World Economic Forum, and what they're trying to depict over here is adoption of technology by the companies, by various enterprises, and they have segregated it as per the technology wise. So you see, by 2022, uh, uh, this is the adoption by the companies, wherein cloud computing will be adopted 72% as a part of their IT technology requirements. Similarly, blockchain, AIML, Internet of Things, app and web market, and then big data analytics. So cloud computing certainly has a bright future, and one has to be well versed. One has to understand the cloud computing world also. And now, one of the things that I'd like to mention, okay, whenever I'm talking about career outlook in AWS cloud or any public cloud platform, I ensure that I pass on this message that learning public cloud platform is not the only thing. You should not focus, or you should not aspire to become a public cloud expert. I mean, this is my personal view. I'm not saying that you do not learn AWS public cloud or a public cloud, but please understand you have to focus on any one of these technologies as well. Public cloud or a cloud computing platform should be a mandatory skill set that you should be carrying, because eventually, whether you're doing AIML, IoT, or a web and app development, or big data analytics, or blockchain, you all will be implementing this on AWS. Okay, so focus on your core interest, the core competencies around the other technologies, other platforms, and learn how is it that you can achieve that thing on a public cloud. Okay, so public cloud platform is an enabler. It provides you a lot of pre-built services so that you can achieve any of these use cases, any of these technologies with ease and with efficiency on public cloud. So focus on your core interest. Learn the other technologies, whichever area your interest lies. Security is one thing which I forgot to mention over here. There's a huge potential in the security domain. If you want to take that up as a career option, amazing thing. AIML is something which is going to change the world. It's already doing it. IoT, I mean, the billions and billions of devices are already on as an Internet of Things, right from your wearables up to IoT sensors for industries. So these focus on these technologies, learn on these technologies, but learn it through public cloud platform, because it will be easy to experiment and learn. Knowing public cloud platform is mandatory. That is why I have there's a career outlook to it. So you can't say I'm a developer but I do not know how it works on the cloud. You cannot say that I am an AIML expert. Why don't you give me 10 servers of some TBs of RAMs, because I do not know how it works on AWS. So it is a mandatory skill set. You have to learn AWS so that you can implement or achieve any of your other technological interests. So your primary skill set will be any of the other technologies of your choice, and a mandatory skill set is going to be your AWS public cloud, because that's where you will be implementing and creating your application and your ideas, right? So that one thing is what I make a point that I share it with everyone. Indian cloud computing market. So that's just, I've just tried to put some attractive and very intuitive, I mean, interesting statistic how large the market is going to be. This is going to be pushed a little bit because of the COVID-19 crisis. But I have an interesting point to make on the COVID-19. India is going to see over more than 1 million cloud computing job roles by 2022. What are the various jobs? So there'll be job openings for cloud architects, cloud software engineers, cloud enterprise architect, cloud infrastructure engineers. So an infrastructure engineer could be a database administrator, could be an operating system administrator, could be a network and security administrator, but they are going to do that infrastructure administration on the cloud. Okay, you can be architect of an application, you can be an AIML application architect or an IoT application architect, but you'll be implementing all of this on the cloud. You can be a software engineer or a software architect who knows how to construct, define, and create a flow of a software, but you'll be doing all of this you'll be developing, implementing, and automating all of this on a public cloud platform, right? So that's why, again, I repeat, the importance is that AWS is what you have to learn as a mandatory skill set. Now, what is the COVID-19 impact? You see, I mean, every industry, Every country has already walked into a recession because of the COVID-19. Industries are badly affected. There are some industries which are kind of crushed because of this, but the opportunity for cloud is shining brighter than what it was. You see, during the COVID-19 impact, most of my own clients who have moved onto the cloud, they did not have to worry about availability of their infrastructure. So here, during this crisis, people were able to spin up thousands and thousands of virtual desktops so that they can securely connect to their enterprise application without worrying about data loss, data theft, data, data, what do you call it, compromise, because they were able to create, within few hours they were able to spin up multiples and multiples of virtual desktops on the cloud. I mean, this was not practically possible on premise because it would have required procuring hardware, licenses, and then again, you need people to be there on the ground. If it is your own data center, nobody else is going to take care of it. But here, as we have mentioned and as we have been listening so far, AWS is keeping the lights on. Infrastructure, power, something as important as cooling, your network. I mean, these are the times you must have gone through the internet, that these are the times that the network attacks on the application has improved, has increased like anything. I mean, AWS is absorbing, ready to absorb huge amount of DDoS attack or any kind of intrusion on the hardware level, on the infrastructure level. Clients are more convinced, are happy that they do not have to invest time, money, the effort of their people in managing their own infrastructure because it's all up and running. All they had to do is ensure connectivity, right? And now their application developers, database administrators, everyone are working from home without even worrying about the availability of the infrastructure. So now the adoption of cloud by various enterprises, and not just enterprises, small and medium sized businesses, your small and medium sized corporates, startups, everybody are going to accelerate the adoption of cloud. Everybody would want to move onto the cloud because they want to achieve the what do you call it? I mean, whatever they have learned in this COVID-19, that is going to have a good, huge impact. And largely, the IT budget is going to be cut down by in businesses, because I mean, because of the business loss, every budget will be cut down, and so will be the cost and budget for IT department. So everybody, every and the CIOs would be under pressure, the IT heads would be under pressure to run a lean IT, okay, both in terms of cost and also in terms of operations, which is where public cloud platform becomes the best platform to have your infrastructure hosted. So the impact of COVID-19 is that the career outlook, the opportunity in cloud is going to be far even more brighter than what it was pre COVID-19 issue. Okay, I mean, all my hearts with those affected by this. We are all affected by this, and we just hope, we pray that we come out of it. We are slowly coming out of it, and very soon we'll be out of it. So let's hope for that. But yes, just to end on an end note, the public cloud platform and the public cloud career are going to shine after COVID-19. Okay. Training and certification, I'll have to run a little bit. So there are free learning and hands-on labs. Hands-on lab, as I would say, there is a platform called Quick Labs. I mean, it's a paid platform, but you can create an account over there. There are a lot of free labs also. Play with those free labs, and if you wish to do more, you can purchase the credits there and start doing it. But then, as I said, for a hands-on lab, you can create a free account. Maybe you folks can get into a group, create a free account and start playing with the services. But be careful that when you create a service, make sure that you're aware about the free tier pricing model. Understand what are the limits for every service to use within the free tier. Otherwise, you will simply end up paying a huge amount. Okay, so be careful over there. Otherwise, and that's why it's recommended that, instead of creating your own account, it's better to pool in, get into groups, and subscribe to Quick Labs and create your account over there, purchase some credit over there, and then do the labs as many times as you want. So that would be a better way. It will ensure that you do not end up paying unnecessary amount. Free learning, let me take you to the web page. So you see, you have to create an account over here, and then over on go to AWS training and certification. I will be sharing this link also. You can simply go to aws.training, and then you can see there are various domains as per the service wise. As per skill level, there is fundamental trainings, there is training for intermediate and advanced. For domain, there are a lot of people interested in machine learning. You can go ahead and take trainings on machine learning. Let me see what's there in machine learning. So you see foundations of machine learning on AWS, AWS Batch for your machine learning. SageMaker is something, again, a completely managed service which can be used for effectively model and train your machine learning models. So there are a lot of such free courses available. Create an account. They don't. It's free of charge. There are tons of services. Best place to start with your AWS training. Okay, go ahead and explore the site completely, and try to learn as much as possible from the free one. So this is about free learning. Then your hands-on lab, as I mentioned, certification overview, hands-on tutorial. So this is one good site wherein you can go ahead and go through a lot of tutorials. So you, again, amazon.com, getting started hands-on lab. I will be sharing all of this links as well, or maybe it's better that you can make a note of it. Maybe you can take a screenshot or something. Once again, so this is your free learning. I mean, it's easy. You can just go and do a search on Google. But in case if you wish to make a note of it, I'll just pause for 5 seconds. You can take a screenshot or make a note of it, and then I'll take you back to the hands-on lab. What do you call it? Sorry, the free tutorial page. Okay. Moving to the next slide. Certification and learning path. So this is one place. A lot of let me click on machine learning and see what all tutorials are available. So you see introduction to deep learning. There's a video for 20 minutes. Train a deep learning model. Again, a tutorial for 10 minutes. A hands-on tutorial. Okay. So you don't get anything to, by the way, implement. It's just a tutorial, step-by-step tutorial, which you have to implement on your own in your own account. Detect, analyze, and compare faces. See, you see this. It's a free tier, which means, let me open this. I'll show you what a free tier hands-on means. So they have also given you the resources that you create for this particular tutorial. You see there's a step-by-step tutorial along with snapshot, step 1, step 2, 3, and 4. So if you try to implement this tutorial under a free tier, these services, the set of services, are all eligible for free tier. So which means it's safe to go ahead and create your own account and try this particular tutorial. But everywhere else, if you see, they have not mentioned a free tier, which means if you try to do those hands-on, it will incur some charges, and sometimes the charges could be really very high. So be careful. But yes, explore this. There are tons of tutorials available. A good way to start. After learning, you can go ahead with these tutorials also to understand. There's a page on certification. So yes, so these are the certification tracks: foundational level certification, cloud practitioner. Then there is an associate level and professional level. So here you can start with the architect, and then there is a certification for sysops and administration. I always recommend that to start with the developer. That is easier. But then no, don't stop over there. The solutions architect certification is something which is highly recommended and the best certification, because here the breadth of all the services, typically all the services or most of the services of AWS, is covered over here. The beauty of this exam is there are no factual questions. The questions are all scenario based, and that's the best way to learn. So when I say an EC2, what are the scenarios wherein it can be used? And there will be use cases wherein they say that I want to host an application, and it's going to host a dynamic traffic. Which feature of AWS compute should I be using? So you'll be able to relate with the real-time scenarios, and you'll be able to relate the services and the features with the real-time scenarios. That's where you get the confidence and grip over the AWS concepts. So this is my favorite certification. But if you want to start with something which is easier to pass, developer is easiest to pass according to me, then go ahead for the solutions architect to have a complete understanding of AWS platform. SysOps is something which is tougher. Of all these three certifications, this is the toughest, and this is focused on your administrative skill sets, wherein you'll design this infrastructure further to ensure fault tolerance and availability and monitoring aspect. Further, there are professional path as well. You can become a professional architect or a professional DevOps engineer. We'll not discuss about that. Specialty is also available. You can specialize in networking, security, machine learning. I see a lot of people are interested, so you can go for a machine learning specialty as well. Alexa, I mean, this is becoming a very popular certification. You can build your skill set around Alexa, and then data analytics and database. So I mean, data analytics again, and this is what Hadoop is not data. Hadoop is not AWS. Hadoop is just one of the use case wherein you can spin up the required infrastructure on AWS and implement it. So you can do all sort of certifications. If you wish to gain more details, more guidance or understanding about any of this application, Shruti is one of the point of contact from our end. She's also connected with the coordinator in your college. You can reach out to her, and then we can plan some session, deep dive session on certification tracks, various certification tracks, maybe starting with a cloud practitioner and then further progressing towards any of these associated programs. Okay, feel free to connect, reach out, and we'll be able to take that further. AWS Summit online last week. The online was, I mean, the summit, AWS Summit. It's not an online summit that happens, but then this time due to the COVID-19 issue, this happened online. Let me just check. I've not opened that page. I wanted to show this to you. Summit Mumbai. If the tracks and everything is available, watch on demand. Perfect. Go to the summit online, and I will request, even before you go to anything else, please go to the summit online. There are tons of tracks which is available to view on demand. Let me just show one of it. If you're okay. Okay, I'm sorry, I will not be able to show you because it will require me to open my email and open my registration link. But yes, I'll give you a walkthrough. Go to the summit, register, and this is currently available on demand. Register it. There are multiple tracks, right from beginners up to advanced level. There are videos, there are tutorials, there are interactions, interviews, tons of stuff to explore it. You'll actually get the feeling as if you are in an AWS event and in a lounge and talking and interacting with the best of the experts. A lot of interactive sessions. There are a lot of sessions, recorded sessions. Everything is recorded right now, but sometime back in the last week it was live. So please go ahead, register yourself, and right now it is available on demand. Visit this summit. Okay, great learning over there. Maybe you'll get a lot of idea in terms of where to start instead of going through various links. Okay. So, okay, we have 5-6 minutes. Let me just randomly take some questions. And as I promised, after sometime after this session, as I get time during the week, I will answer each and every question and pass it back to you guys. Okay. Um, Let me take one question from. Okay. How is AWS cloud computing better than the leading companies that provide cloud computing services just like AWS? I think we have compared we have discussed this question about comparing various cloud platforms. Can you explain me more about serverless technology and its financial structure? I will give you just a brief, not much in detail. This question is from Nidhi Singh. So Lambda is a serverless function. When I say serverless, there is no need to think about operating system, server, virtual cores, RAM, networking, storage, or anything. Okay, let's first compare a server versus a serverless. When you create a server on public cloud platform, the moment you turn on, you start paying for it. The billing happens per second. Okay, but with Lambda, which is a serverless, you just have to write a code. Let me quickly show it to you. I will not execute anything, but let me show it to you. So let's say if you are a developer and you want to create a application, this will give you a very good idea of how different a serverless is. Okay, so I mean, the fair discussion is, I want to write an application, I have a code. Now the first thing is required, I need a server, I need to install an operating system on top of it. I will have to create a runtime environment. Let's say if I want to create a Java application, I will have to install the Java runtime, which means there is a server that is required. Okay, but all I'm doing is I am focusing on, of course I'm going to create a, I'm just showing, just for the sake of showing. Okay, showing I can write my own code from scratch, but I want to show you how a code looks like. Configure. Now you see, as a developer, all you have to do is do your job over here, right? Wait a minute, create a function. Let me to take you to the entire actual console. Is it creating? Sorry, test. VIPS. I'm going to just pick up the defaults. I do not know what function it does. I'm not going to execute it. I have to create a test, execution and all of that. But I just wanted to show, this was your code. You wanted to run it somewhere. You had two options, either go for a server, provision it, install on top of it, ensure connectivity from internet and things of that sort. And the other option is go for a serverless, wherein you just uploaded your code and here is your function loading. Next time, all you have to do is create more pages, and keep adding your codes, keep building your application, make it the way you want it, right? And then start running it. So you have to create a test event and then test it. You can see the immediate input and output. You see, I have the option to choose runtimes as well. I can develop a code on .NET, Go, Java, Node.js, and Python, and Ruby, and whatnot. Okay, so all I have to do is choose my platform, write my code, and run it. Now the pricing construct of it is such that only when I'm executing my code, the duration of time for which the code is getting executed, and the amount of memory that I'm going to consume during that execution, I will be paying only for that. Unlike a server, the server, the moment it is turned on, whether your code is running or not, whether someone is requesting anything from it or not, you still have to pay for it as long as it is running. Here, you pay only when your code gets executed. So that's a huge amount of savings. Okay, and plus, I mean, as a developer, you don't have to worry about anything. Go ahead, upload your code, and start working on it. So that's one difference. Okay. Does SaaS cost more than PaaS and IaaS? This is a question from Priyanshu Chaudhary. Very good and very interesting question. So you see, costing. There are various reasons by which you think about cost. From a business standpoint, sometimes running infrastructure on infrastructure as a service, which is a server, is my need because my compliance requirement, regulatory requirement says that I should be able to do a hardening of my operating system as per the standards of my organization, or let's say as per the standards mandated by the industry. In that case, I have to bear the cost. But then yes, because I'm complying to my business requirements, that's the best option. So here, hence it is cheaper. I'm just trying to build a context around what is cheap and why something can be called as costly. But let's say I am not having any such boundaries, and I have to do away with the overhead. So I will choose a PaaS. From if I choose compare the cost of one server versus an RDS, a PaaS platform, the cost of RDS will always be higher. But look at the savings that you're going to do when you move onto a PaaS platform. The time and the effort and the cost for managing server, storage, networking, and everything is also what you're going to save. So while you'll be paying more for the services, but on the other hand, you'll be saving a lot of time and effort of your resources, which is again a cost benefit for you, because the effort is what you pay for every resources, right? There is a cost attached to it. If you're able to save that effort, you'll be able to use it in different projects, right? So that is again a saving for you. So there is a way to look at where you why you say it is a cost saving, why you say something is costlier. So yes, from infrastructure as a service, if you go to PaaS, it will look costlier. From a PaaS, if you go to a SaaS, it will look far more costlier, because the SaaS provider is going to invest the amount and time and the amount of effort and everything to give you that particular service, and hence they are going to charge it, right? So if you compare it, just what do you call it? If you do an as-is comparison, a like-to-like comparison, it will appear costly. But when you look at it from the business perspective, the context of from the business owner perspective, you are saving a lot of effort, and hence you are saving the cost for your IT operations. So that is how we also do a TCO. The reason why I said a TCO calculation, I said is it's an interesting question, is because I come across this question when I'm talking to all of my clients. They say that the server is cheaper, why should I go for PaaS? So I have to tell them we have to do an effort analysis, we have to do a TCO analysis, saying that this is where you are saving the cost, and most importantly, the ease at which you can do innovation. And you remember the graph in one of one of our slides, the 30% versus 70%, and then that gets flipped. You get 70% of the time to focus on your business innovation, and 30% of it is required only for managing your infra. So there are trade-offs. It is just the way you want to look at it. Okay, so we have reached the time. I mean, as I said, I would want to repeat, I'm not really feeling good that I'm not able to answer all of the questions. I really liked the enthusiasm, the interest all of you have shown throughout this session. The number of questions that I have got in my chat room only proves that you were able to you were all interested. And I also feel humbled by the fact that I was able to share some of my knowledge. I feel good that I was able to contribute somewhere in your education, in your interest and things of that sort. Really great connecting with you. I want to promise you again, I will make sure I answer each and every question and we get back to you. Okay, thank you very much to everybody Thanks again to the VIPS department. Thank you to the dean, and thank you to the faculty coordinator. It was really a great opportunity, a great platform provided by VIPS to connect with the students, and we are really looking forward to connect again and again whenever there's an opportunity. Uh, Thank you very much. Have a great rest of the day. Please take care of yourself and stay safe. Bye bye.